To continue with our discussions, we have amino acids and peptide linkages. In proteins, amino acids are joined by peptide bonds. Okay? So that is a string of amino acids are joined together by peptide known as a polypeptide. Or peptide plus peptide, that is a polypeptide. And when you say oligopeptide, these are chain of amino acids that is not not more than 25 chain or less than 25 chain. So that is considered to be the shorter chain of amino acids. Okay? So peptide bonds are amide linkages. Okay? Try to see this one. This is the amide. And by condensation of alpha carboxyl group and one amino acids with alpha amino of another amino acid. Meaning, when you say condensation, there is what we call a bond that is being joined together by two amino acid. Okay, they are being joined together in condensation process. So try to look at this diagram. So amino acid plus amino acid that is undergoes the condensation process, it will lead to the formation of peptide bond. So if you reverse the reactions, you have to add water and undergoes hydrolysis process. It will form now another. It will go back to one amino acid plus one amino acid. Okay. So peptide chains of amino acid. So we have the N terminus and the C terminus, or the N. You say terminal N. So the polypeptide chain are composed of the carboxyl terminal N and the amino terminal N. So this is an example of your protein fragments of molecules that less than 25 chain, the oligopeptide. And we have the or amino acid that is being linked by disulfide bond. So for example, we have a drug known as oxytocin, okay, that is used in the contraction during labor. Okay, and vasopressin is antidiuretic hormone. Usually they differ only in the second chain. So these are composed of leucine, this one arginine, and we have isoleucine and phenylalanine. So mostly almost the same na yung structure nila, and they are linked by disulfide bond or sulfur to sulfur bond based on their polypeptide chain or structure. So protein classification. So proteins are classified into globular proteins and fibrous proteins. So fibrous versus globular. So you have, when you say globular, that is compact. Ito extended. Okay, mostly fibrous proteins, ito yung mga actin, myosin. These are muscle fibers that is responsible or that are responsible for contractions of the cardiac muscles or muscles of our body. Okay, soluble in water. This one is insoluble. So this is composed of secondary structure. This is secondary structure but simple base. So this is composed of alpha and beta sheet. So later on we'll discuss that one. So this is composed of quaternary structure. This one quaternary. So non-covalent, this is covalent bond. So that is the difference between the globular and fibrous. Okay. Function in all aspects of metabolism, enzyme, transport, immune protection, and hormones. Okay, these are globular. So this one for tendons, bones, and muscles, usually mechanical functions ang mga fibrous proteins. So example niyan, so you can see the globular proteins at the surface of the cells. Okay, so this one, the globular proteins. Receptors also are found in this structure. Okay, and tendons, example niyan, tendons, we have the muscle fibers there. So this is known to be the example of the fibrous proteins. Collagen fibers itself. So collagen, we have fibrous protein, the white fibers, and we have myoglobin. This is globular, example ng globular. We say myoglobin is oxygen binder. Hemoglobin is the oxygen carrier, I mean. Okay, next. So general biological functions of proteins. So mechanical support and cushioning. We have collagen, elastin. Okay, yellow fibers is the elastin. You have mechanical work. Actin, myosin, and tubulin are responsible for the muscle contraction and even relaxations. Okay, and catalysis, enzymes, ribonuclease. These are enzymes that will hydrolyze your ribonucleic acid. So what are the example of the ribonucleic acid? We have the deoxyribonucleic acid and the ribonucleic acid, or the DNA and RNA. So we have hexokinases. This is an enzyme that will convert your glucose to glucose 6-phosphate during the process of glycolysis. And we have DNA polymerases. So these are enzymes involved in DNA polymerization process or during the transcription process. Transport and storage, we have hemoglobin, the carrier of the oxygen, and we have myoglobin, oxygen binder, and we have serum albumin. And communications and defense, antibodies, peptide hormones, neurotransmitters, and receptors, of course. These are the biological functions. So usually communication and defense. So secondary higher structures, we have the primary structures. Macromolecules such as nucleic acid refers to sequence of covalently bonded residues. So polypeptide chains determine its primary structure. So this one is example of a primary structure. So this is composed of one chain of amino acids, okay, regardless of the length.